G'day there, you're watching the Aussie BIM Guru, and today I'm going to be covering a fairly quick tutorial to show you how to transport CAD blocks into Revit. So essentially how to migrate a CAD block into a family position. So I want to disclaim this isn't going to create 3D Revit objects from CAD blocks, it's about how to position something based on a CAD block instead. So essentially we're going to take the Revit sample project, we're going to export a DWG with the trees as blocks as well. We're going to delete all the trees because we're going crazy like that. And then we're going to insert the CAD link and we're going to place families based on the block names and the positions of the blocks. So this workflow could be used for obviously a file where you don't have the source in Revit. So you could read the block names and make them line up to particular family types. But I'm going to show you how you can use this using some custom packages. So a pretty handy workflow, especially for placing trees on site plans, which is quite a common task. So we're going to be using mainly a package called LinkDWG. And this is a brilliant package that lets you fully access AutoCAD whilst you're inside Dynamo. So essentially it will either open up a linked document or it will actually source a CAD document, and it can actually read your selection in AutoCAD, and it can also take all the blocks and lines and polylines out of the CAD document for use in Revit. So really powerful and not really very well known, surprisingly. Biomorph is much more well known for interacting with CAD, but this has much more potential, I think. But obviously Biomorph does a lot of other things as well. And we're going to be using springs in order to just put the elements that we create onto a selection, because we're going to need to rehost them to a topo surface after. So ideally use something in the version 2s. I'm using 2.0.3. I think anything in version 2 should probably achieve this. But let's get started. So I'm just going to jump into the Autodesk Basic Sample project. I'm just going to go into 3D. By default, people don't realize it, but there's actually more than 4 trees in the sample project. So if I turn off my section box, voila, there's some more trees. And the reason that is because they fall outside the section box, and planting by default will turn itself entirely off if it's outside a section box because of the way it represents itself. So a bit of a strange little behavior there. But what we're going to do is just go to the site plan, and I'm just going to turn off shadows, and I'm just going to export this as a DWG from Revit. And I'm just going to make sure that in my settings, under units and coordinates, it's set to project internal, and that we're using the same units as the project, millimeters. I'm just going to export this, and I'm just going to export this to this CAD block file or CAD block folder that I'm going to relink it into. And then what we're going to do is delete our trees. Before I delete them, I'll just draw emphasis to the fact that they have different types for different tree species. So typically when CAD blocks are created from a Revit export, they'll be named based on the family type and family. So you can see we've got different species. So these aren't just all the same tree. So we're going to want to source the block information to place the right family instance per block location. But what I'm just going to do is do an isolate category if you're following along at home, delete all my trees, and then I'm going to go back to my site plan. And I'm going to relink in my CAD file as my source for my trees. So you can imagine this might be a project where you have no trees and there's a survey you receive which has all the tree markers as blocks, ideally. So we'll just do auto placement in this case. And it will just come in, I believe, at the level that we're on currently, level 1. And in here we have a variety of CAD elements. So if I select my CAD file and I query some of these objects, we'll see that they're on a layer called L-PLNT. We can't see the block information, but I could open this up in AutoCAD. What I'm going to do instead is start using the LinkDWG package to start interrogating the CAD file. So I'm just going to jump into Dynamo in a new script. And what I'll do is just start by selecting my CAD link using select model element. And I will just select this link as an object or an element. So what I'm going to do is start using the LinkDWG package now. So what I need to do is get all what are called the COM objects from the file. So we're just going to go get COM objects. And this is from the LinkDWG package. So I just need to find the right one. So get COM objects. I believe this one's the wrong one. That's the one you use for your selection in AutoCAD if you don't want to work with the linked file. Believe this one, yes, this is the one that we want. So actually no, we're using this one next. What we want first is we want the import instance get com objects. Yeah, that's what we want. So we're going to feed in our linked CAD file in this case. But just note that you can use this node, the alternative one, just to read your active selection in AutoCAD, which is pretty cool. But I guess from here we can either say, do we want to see our AutoCAD file? I'll just say true in this case, and we'll see what we get. What I'm going to do then is take my COM document and feed that into my DBX document. And I don't know quite what all these things mean. So if you're interested in finding out what all these acronyms stand for, maybe it's worth doing some reading and research on the package. It's quite advanced. A lot of it's probably AutoCAD lingo. I'm not really an AutoCAD user by default. So apologies if it's really obvious to a CAD user. What I'm going to do is just feed a boolean into the run. And at this point, we can essentially get all the properties of our file. So what I'll do is just run my scripts, and what this should do is open up the DWG file in the background in AutoCAD, and it's going to read all the properties of the file in Dynamo. It can be quite slow, so because it's actually collecting pretty much everything. So if I expand this list, which will be quite slow, I might maybe just look at a watch node in one of these subnodes instead. Yeah, I'll just get a watch node. It's easier. Let's just look at our blocks. So there you go. You can see we get a whole bunch of system COM objects. In this case, this is all the blocks in our model or in our DWG file. So it won't just be our trees. It'll be anything that becomes a block. So what I'll do is just move this watch node off to the side. And I'm just going to get a block properties node. And there's a properties node for nearly all of these, or if not all of these COM sections. So there's so many more things you can get out of your CAD file, such as text or model text, hatches, regions. It's really powerful. So have a play with anything that you need for your particular CAD read. One workflow I did show a user once is to select polylines out of CAD for the outline of an apartment, and then create walls based on those lines inside Revit by selecting those polylines one at a time and reading that selection. So there's a lot of creative workflows you can use with this package. And it's again, it's not really very well known, so pretty exciting. What I'm going to do is just do a watch node on the block name before I run this again. And you should see the names of the blocks. And now we're going to see things that are a bit more recognizable. So you can see we've got our wind generators, we've got some tanks, we've got some photovoltaic cells, we've got some railings, and here's our trees. So we can actually filter down our blocks based on what they are. So one thing they all have in common is that they have the word tree in their name. You might want to pick something more specific, because maybe sometimes something else will have tree in its name, but in this case we're just going to go with tree. So I'll just delete this, and I'm going to use a string contains node, because these are all coming out as a string. And I'm going to check if the block name contains tree, and in this case we will not ignore case. And what we should get is a true false mask that we can pass across our blocks to find just our tree blocks. So we're going to do a filter by boolean mask, and we'll take our block names and mask them. And now our in list should just be our tree blocks and their name, or in this case just their name. What we're also going to do is we're going to also get their points. So you may not have realized, but in the background I've actually got all the points for my trees in my file, so that's really powerful. I'll just see if I can fit them in my viewport. There we go. So there's all my block points or origins. So that's typically the center of the block. And in the case of a tree, because it's a circle, it is the center and the placement point for the tree as well. So that's great. When you're working with something that the center point isn't the placement point, you'll need to figure out the offset to achieve the placement point in Revit versus the block in CAD. So that can be quite complex. I'm not going to focus on that in this workflow because it's a little bit too complicated. But let's just filter our points as well. So I'm going to turn the preview off for my block properties. And for the insertion point, I'm also going to mask it based on whether it's a tree. In this case, we get our in and our out mask. So what we want to do here is actually, I'll just put a watch node in here for the in list and turn off the preview here as well. Actually, I might I'll do a list create so you can actually see the preview geometry. Whoops. There we go. And now we just get our trees. So if we go back to Revit, we think we can probably just place families on this straight away. But unfortunately, in Revit, everything's not quite at the right angle. And the reason this is because of the relationship between the coordinate system in Revit and the coordinate system in CAD. So what we actually need to do is rotate our points about the internal origin in Revit by the project north to true north angle. So in the default Revit sample project, if I just go to site and turn on project base point and survey point, and if you're in Revit 2020.3, I think it is, you can actually see the internal model origin as well. We can't currently. But the internal model origin point, I believe it's somewhere around here in the model. I don't know why, that's just where it happens to be. And that's where you start in Revit when you first set up a model. A lot of the time it's a very arbitrary point, but it's a very important point. So we also have a project base point and a survey point, which aren't important in this case. But the thing that is important is that the project base point has a rotation to true north that we want to read. So if I can just isolate the project base point, you'll see that we're at an angle of 323 degrees at the moment. So we're going to need to rotate our points by this factor in order to correct the coordinates discrepancy. There might be other ways that coordinates are discrepant between files. For example, if you're using a shared coordinate system, I haven't tested this yet, so you may need to look at other elements such as your internal project origin and your survey point location, but this should work for anything without a shared coordinate system at least. So what I'm going to do in this case is I'm going to aim to rotate my points. So we're going to do a rotation of an object around an origin, an axis, and a degree. So we're going to be taking our points, and in this case, our origin is going to be the Dynamo origin, which is also the Revit origin as well. So we're just going to create a point origin node. You could also do an XYZ point of 0, 0, 0. I just find this as a cleaner node to use out of the box. For our axis, we're going to be rotating around the Z-axis because essentially our axis points up and we just turn around that axis, if you can picture that. That was a pretty terrible example. And all we need now is the degrees. So we need to find the angle to true north. There's a lot of custom nodes that do this. I'm not going to use a custom node here. I'm just going to use an out-of-the-box workflow. So if we just get all element types and we drop down to base point, this will actually give us our project base point and our survey point, which a lot of people don't know. There's a lot of great nodes that get the project base point and the survey point, but I find if you can avoid using custom nodes, sometimes it's better. We're going to get all elements of type now. So we want to get all base points in our project. So all elements of type. And essentially we should get two base points at this point. So one of them, the first one is our survey point. The second one is our project base point. If you need to check which ones they are, all you need to do is probably just get a parameters node. So parameters node is a really handy node for assessing information that elements contain. And if I run this and I have a look at all the parameters that belong to the element, I can see this one is my survey point and this one is my project base point. And I can see that there's actually a field in my project base point called angle to true north where I can get that precise number. So what I'll do is just get the item at index 1, which is my project base point. So I'm just going to say project base point equals my list at index 1 with a square bracket, just to isolate that project base point. And what we can do there is just do get parameter value by name. And the parameter that we want is angle to true north. And it's important to note that angle, true, and north all have a capital letter, but true doesn't. It's always important to check case when you're doing things like this. And what we should get is the value of 323, which we do as a number. And we can feed that in as our rotation. So now, if I rerun my script again, we should rotate our points around that point. So now if we go back into our model, you can see that now our points are coincident with our CAD file. So we're pretty much ready to place families at this point, but we don't know what type of family we want to place yet. So we need to read the name of the block in order to find the right family. So in this case, it's quite easy because we can actually read the name of the block directly to get a family type. Otherwise, you might want to use something like an Excel file to map blocks to specific families in Revit. But in this case, I'm just going to do a straight reading of the block name instead. So we're just going to go back and get our block names again. And what I might do is just I think it's this filter by Boolean mask here. I'm just going to put a watch node here so we can see what we're filtering. But essentially we want to be able to pick the type name out of this, because our destination node that we're heading towards is going to be our family type by name. So if I do family type by name, it's going to find the first family, the first family type of this specific name. So eventually we want to get the name exactly as it occurs, but there's a little bit of formatting we need to do first, because there's a few things you'll see in the block name that are different to the family type. So obviously the first thing is we have RPC tree deciduous, which is our family name. After that we have our type name. And then at the end we have some ancillary data, I believe related to the, looks like the work set. So this is probably, I don't know if that's the work set or the layer, but I believe it's the category. No, I'm not sure what that site relates to. I believe that's the layer in AutoCAD. I can quickly check what that is actually. I'm not quite sure what that site means. No, it's not there actually. I'm not quite sure where those properties are coming from. I can try and find the properties of this object and see if it's a CAD derived property. It doesn't seem to be. It's something to do with how the block is named coming out of Revit. A bit strange, but let's ignore that. So essentially we're trying to format our text to extrapolate just a little bit of text in the middle. So what we'll do here is we'll split our string. So we're going to use string split. And we're going to split it based on two things. So the first thing we're going to split it on is the deciduous dash. And that way the next thing we get is our type. And then we're also going to split it based on, in this case, the underscore dash. So what I'll do is just create a code block and we'll just go deciduous space dash space. And then our other separator is underscore dash. And what this will do is give us sublists broken up by our separators per string. So you can see now we have our type name sitting in the middle at index 1. So we just want to use a get item at index node. And in this case, we want to operate at level 2, because you can see we're working at each sublist. So we'll do level 2, and then we'll get index 1. And this should leave us with the type name. It's interesting that in this case, it leaves out the apostrophe at the end. So if you go back in Revit, you'll note that the planting has a number and then an apostrophe. I'm not sure why that gets left out in the block name, but what we can do in here is just add that back. So we'll just go plus. So we'll go name plus that apostrophe. And that should concatenate that onto the end of each family type. And as you can guess, we can just take that name and get the relevant family type. And now for each tree block, we have a family type that we can place. So you can see these are actually Dynamo elements now. So that's pretty much it. From there, really what we're going to do now is place the families and then select them after we place them. And the reason for that is because they're going to come in at just the level that the CAD file's at the moment. If there were 3D objects in CAD with a height, maybe you wouldn't have to, but in this case, unfortunately, they're not. So what we're going to do is rehost them to our topography. So we're going to use a family instance by point. So family instance by point. And we're going to place this family type at these points. So we should have a list of points, 16 points, and 16 family types. And all we're going to do after that is feed in our select in Revit node from springs. And this will select these elements once the script finishes running. So what I'll do is just minimize Dynamo so that we can see Revit, and I'll just go to a 3D view. But this is quite exciting. So essentially we've actually built a workflow for getting CAD blocks into Revit to families, so quite powerful. So I'll just run this, and there we go. That's how quick it was. It's created all those families. Obviously at the moment, they're not really sitting on the topo. So an interesting thing that I found out is after families are placed, you can't immediately host them to a topo. You have to host them to a level first and then to a topo. So if you just host them to say one of these levels, and then host them to the topography after. There we go. So there's our trees back in Revit, hosted to our topography, and each type is back in correctly based on its block definition, which came out of Revit in the first place. So a pretty powerful workflow, and there's a lot of alternatives for how you could use this. This is just one example, so definitely explore this package. LinkDWG is sinfully unknown from what I've seen and can do a lot of great things. So thanks for watching today. If you've got any feedback or comments, feel free to leave it down below. I upload videos about twice a week, and I hope to do so for a very long time. So if you're not already following and subscribing, feel free to do so, and hopefully I'll see you in the next video. Thanks, take care.